We also have a quiz tomorrow, Wednesday. So if you're watching this Wednesday, yay. If you're not, you're watching it early, great. All of it is good stuff. Keep up the thinking. So again, use these videos, skip through them for your understanding, and then ask me those great questions. Give me that feedback. Be like, Mrs. Reynolds, this, that, or the other. Whatever you notice, whatever you think would help you. I'm here for you. I am here for the math and the learning. And I joke and I tease that I would like to start recruiting for my mathematical army so that we can take over the world together. But I'm kind of serious. I think that I need to create this mathematical army of thinkers, and then we will take over the world like Pinky and the Brain. Okay. So on your plan, you can always see the due dates, but in here, you can have access, you can review. So use this course for your success. More rational functions. What? In here, you're going to have examples, you're going to have definitions, you're going to have videos. Oh my gosh, a hole in the graph. Look at that. What do you mean determine a hole in a graph of a rational function? Graphs can have holes in the rational function? What are we coming to? Determine the zeros of a rational function? Oh, so interesting. Go find out what is a hole in a graph? What does that even mean? Like, how does that even come? We're just like, no, we're not going to put that value. Just skip it. Anyway, try to get curious because it's very, very important. Look, before the quiz on your own. Let's go make some mistakes real quick and then we'll go take the quiz. Well, I got a review too. This is part of my review, my thinking, my helping. Yeah, math is huge. There's so much. I'll forget. I'll get confused. I'll have to slow it down. Does that make sense? I do have a lot more experience, right? So you would hope I would never make mistakes, but that's not real. Even my teachers oh, come on. I might pause it while it loads. I'm going to pause it. Oh, all right, it loaded. So what value is excluded from the domain input? Domain, X, domain. Input, because it causes a hole in the graph of the function. What do you think? Let's just think about this real quick. We have options here. Just what we know about math. Say you didn't do any of it. You just want to jump straight to the quiz. All right, fine. That's fine. Use your logical thinking. Here are your options. You could just click, check answer, click, check answer, click, check answer, click, check answer. Why? There's no point. These aren't designed for points. These are designed for check on learning, personal check on learning. In life, out of high school, even in college, it's up to you. It's up to you to do the learning. They'll be there, they'll help you, but there's not that level of, hey, try it, do this, right? It's up to you in your life. 0. If I substitute 0 in, right, we call that function notation. We'd say f of 0 is equal to 0 squared. I'm plugging it in explicitly. For those of you who are fluent, you already know how to do this. You might even be able to do it in your mind. I do recommend, even when you can do it in your mind, try to remember to do it on paper, because as you continue in your mathematical journey, it will get too complicated and you will have to check your work. And quite often, it's this guy. It's that pesky sign, the negative symbol, that will get you every time. So attention to precision is an important skill. And, well, oh man, I just saw it. Oh, like I brought up with the windmills. There's attention to precision that was lacked in the construction of those windmills somewhere along the line, and it causes problems. So let's do it. And mistakes happen. I'm not saying never make a mistake. 0 squared, 0. Minus 16, so it's minus 16. 0 minus 4, minus 4. It's a fraction, but it means division. 16 fourths. It also means 16 divided by 4, or how many 4s are in 16. You're welcome to use a calculator. Negative divided by a negative becomes a positive. You're basically canceling them out. There's other mathematical thinking. So anyway, we end up with positive 4. When we plug 0 in, our input, our domain, into the function, we get a good number, solid 4. That's real. That's fine. It doesn't matter. We're good. What about 4? I'm going to skip -4 only because I can see -4 minus 4 would be -8 in the numerator. And I'm really only concerned with values on rational functions that make the denominator 0. So it's different for each function, what can and cannot be in the domain, what we can and cannot put inside of our function. In this case, typically with rationals, you look at that denominator and you think, will it ever equal 0? If it can equal 0, then that's what we need to check. So let's check 4. What's happening here? We have a 4 minus a 4. We get division by 0. Up here, we get a 16, 4 squared. I'm plugging it in, just like 0 squared, minus a 16. That also equals a 0. So when we have this, 0 divided by 0, Mrs. Reynolds, haven't you been telling us that anything divided by itself is 1? Why is 0 divided by 0 not 1? I don't know. Is it undefined still? Okay. Some of the things that I hope that you start to do independently, just because you're curious, what does that look like? Especially since you have technology right at your fingertips. If you have access to our online school, you have access to Desmos and tons of other online resources. So let's just try it. 0 divided by 0. Oops, that was an O. No. 0.00001, really close to 0, right? Divided by 0.0000001. Oops, I want to do the exact same one. 1. Look, that's really close to 0. What if we added a few more zeros? Let's add. I'm making them exactly the same. That's very, very important. That's very close to 0. All right, so now let's graph our graph. Let's go see if there's a hole. X squared. So I'm going to use parentheses, x, shift 6 to get that caret 2. I'm going to arrow over minus 16, backslash underneath the question mark, shift, well, actually at this point, now it's in this form, once you get it in this form, kind of like that calculator button that has the square, line, square, now it's already implied parentheses. It's already implied grouping when you use a fraction bar to talk about division. So now I can just do straight up x minus 4. Okay, so here, so this says there's no hole that it equals 0. Let's see. What did I do wrong? Oh, that's not x equals 4. That's y equals 4. Mrs. Reynolds. Undefined. Yeah, that's what it should be, right? We saw the 0 by 0, but I was like very interested because it's not always a hole. How do you figure out if it's a hole? Well, that form. If it's division by 0, right? Then there's a hole there. But because of this relationship, let me show you the factoring. So let me go back. Now we did our exploration. There it is. Haha. There it is. So factor the numerator. I don't have to do it. They did it for you. Once you factor the numerator, you'll see that this x plus 4, it's going to get close to it. This x minus 4 will end up canceling out, but it's still there. If you simplified this expression, and this is what's interesting, it would simplify, right, this whole parenthesis to just x plus 4, which is the line you get, right? We get a line, That's the graph. Oh, did you not think about that? How come this is a line? I hope you did. I didn't even think about it. But this is a line. That's a linear equation. But this is what we typed. And now there's a hole? All right. Anyway, I'm having fun exploring with you guys. I hope you start to ask those questions and just think about math. You are allowed to think deeply about math and ask those great questions. How in the world, if I have this function and I get this wacky wazoo, but now all of a sudden I have this function and I get a line? There's the math, the algebra of what's happening. But this is our original function. So we got to look out for holes, asymptotes, and all of those values that make it impossible to solve. Undefined. Does undefined mean it doesn't exist? Like, why can't we just call that? Why don't we just say it does? Why do we say there's a hole right there? Is there any type of math that maybe we can start thinking, well, it gets so very close from both sides? So, like, maybe what's the limit? Like, I mean, when are we going to say it's undefined? What's happening when we zoom in? I wonder if we could see that. I doubt it. Where's 4? There's 4. Okay. Okay, let's zoom in right there. All right, feel free to fast forward or explore. Let me put the point because I'm getting, it zooms my old brain. Loses it. Where did it go? 4. Here we go. X equals 4. I can't plot that point. So x equals 4 and undefined, right? It won't let me. But at least now I can, because there's a hole there, right? So there's no intersection at x equals 4. That's why it won't let me click on it. It would if I do x equals 4.1. Boop. Hey. Oh, where is it? Oh boy, I know. There it is. Wow, we zoomed in a lot. There's x equals 4.1. So maybe I need to do 4.00000000001. Ha! Take that, computer program. So we should be able to, wow, oh, you turkey. It's too close. Nah. Let me click on it. There we go. They let me click on it. Let me put that point there at 4, 8. Okay, there we go. I'm happy now. Add a label. I can get rid of this line and we're going to zoom in and see. I might have to move the point, but that's okay. At least I can zoom in and see what they show me, if they show me anything. Right, we're talking about the behavior of the graph. I need to stop. I need to get back for you guys so I don't confuse you, but I'm just exploring here, seeing what the computer program is being told how to represent this. We are zooming in a lot. A lot. Notice how it keeps recentering. Okay, let me turn this off. Yeah, you won't see it. So nothing. All right. So anyway, just think about that. I hope to inspire your curiosity and taking that time. It only took a few minutes. And if you clicked through, great. All right. So now we understand there's a hole, even if we simplify it at x equals 4 because it created our original function to have division by 0. Okay. Your time, does the function have any holes? Sure. How about at 0? There's a hole at, oh, now we need to look at the point. So when x equals 0, I don't know if it equals 2. Let me see. Oh, I need to simplify. I see. All right, so here's the algebra. We have this. I can tell that these are the values when x equals 0 and when x minus 3 equals 0. What? Well, that's because those are the two places that will cause the denominator to equal 0. So now let's simplify this. We're going to simplify this using algebra. Remember, we have x over let me zoom in. We have x minus 3 over x minus 3. Well, that is going to cancel and be 1. And we have x, those simplify. So now we simplify our graph, f of x. If we simplified it to graph it, we'd have this line, x plus 2. So there's a slope of 1, and it crosses the y-intercept at 2. Now, is there a hole? Let's see. When x equals 0, this original function is divided by 0, and therefore we can find that point. But now we can plug 0 in this time and actually get 2, right? F of 0, 0 plus 2. So we would have, in fact, 0, 2. So that should be true. There's a hole. What else? Well, we have this negative 3 here. So when x equals positive 3 causes the original function to be divided by 0, we can plug that in. F of 3 becomes 3 plus 2. So when x equals 3, we have an output of 5 now. So there should be a hole there. Let's go see. 3, 5, true, false, false, false. That was the algebra of how I found that. Because graphing, it would take, you wouldn't, it's, as you saw, you wouldn't be able to see it. I was hoping you could, but you can't. We did it. We did it. So we are thinking about still that denominator. What makes the denominator 0? But now we're extending it and we're simplifying our rational functions. We did that way back in semester 1. The concept is still the same. If I have anything that's exactly the same, smiley face divided by smiley face, they end up canceling and equaling 1. So if I have 2x minus 3 divided by 2x minus 3, see the parentheses? That's important. We need the whole group. That would, no matter what x is, that will equal 1. So that's a little review on the algebra. If I have x times x minus 3 in my denominator equal to 0, well, because it's multiplication, this is x times x minus 3, that means either one of those can equal 0. Either factor can equal 0 because 0 times anything is 0. 0 times smiley face is 0. 0 times me is 0. Anyway, okay, let's keep going. Now let's hop to the quiz. Ooh, we got a factor, friends. So much to review. I do wish we had live lessons. I'll see what I can do about this, okay? We need to factor. We need to practice our factoring skills. They don't go away. If you're given these, and we'll go look at the quiz, some test taking strategies, if you're given some solution options, you can just substitute them in and see which ones make the denominator again equal to 0. If not, we could factor in and have some help. Let's see. So if you remember, we're going to end up factoring in the form because there is no coefficient in the x. And that's often how they're going to give this to you guys. I want to show you how to use some programs though too. But for those of you who've got this down, always practice your skills. For those of you who want to learn to use technology, please just let me know. I'll spend a whole time explaining how to use things like Symbolab or Mathaway and what it means, because that's really important. We do use technology. Now remember, I need the inside to be negative, and I need the outside, the final number, multiplied, right? Because we do FOIL, so x times x will be x squared. Then we do outside, inside. I need this final constant term, the plus 42, to be plus. So these two are going to be multiplied, whatever I put here and whatever I put here. The only way to get a final answer of positive is either a negative times a negative or a positive times a positive. Because if either one of these is the opposite, this final number will be negative. So this is a factoring strategy. I split it up into parentheses. I take a look. It's just going to be x because there's no coefficient in front of my x squared term. I determine my signs. This helps me right off the bat. This is what I do. Look, it's either going to be minus and minus or plus something and x plus something. I don't know what that thing is yet. Next, to determine between these two, I look at my middle sign. This is what I do. I've always done it. If that's negative, then it has to be this one. Why? Well, I'm going to end up, let's just say, with plus 1 and plus 2. Then inside, after I FOIL, I'll get x squared plus 1x, which is plus x, plus 2x, which is all positive, and then plus 1 times 2 is plus 2, right? But inside here, we have x plus 2x, like terms because they're powers. We can't do anything with the squared term because that's a different power. When it's a like term, it's the same exact variables to the same exact powers. That's what a like term is. Then you can add, subtract. You can add and subtract like terms. You deal with the coefficient. Remember our invisible 1? So 1x plus 2x would be 3x, but it's a positive. So no matter what I put in here, if both the signs are positive, my middle term has to be positive. So that's a tip. If you have an x squared plus something, then it's going to be an x plus x plus. If you have a minus then a plus, it's going to be a minus minus. If you have a minus minus, then it's going to be a plus minus. That's just, I don't know if that helps you, but if you want that written out, if you have your standard form ax squared, this is good for notes, plus bx plus c, standard form of a quadratic equation, you are going to have, for this one, it has to be plus plus. If you have an ax squared, now if a is 1, if a is equal to 1, which it is over here, there's an invisible 1, then it would just be x plus x plus. But I'm leaving it in generic form. So if you have ax squared minus bx plus c, then you know it's going to be x minus, well, if a is 1, x minus. And then finally, if you have the final, this is a good practice of logic too, by the way, listing out the different possibilities. Takes time, yeah. Plus bx minus c. Or if you have an ax squared minus bx minus c, you're gonna, an a is equal to 1, you'd have an a, I'm trying to make sure this is absolutely true in all situations. You'll have an something. These are blanks. These are numbers, actual numbers that have to do with c. Factoring strategies. If this makes sense, great. It had to do with what's going to happen next. If it doesn't, throw it out. Throw it out. We're going to look now at c, this constant term, 42. We need to do the factors of c. Well, I know there's 42 in 1. 42 times 1. I know there's 6 times 7. Aha, I'm going to stop right there because my mental math says 6 plus 7 or negative 6 minus 7 will be negative 13. So again, I have x minus 6, x minus 7 is my factored form of my denominator. That lets me now find the zeros. You could use the quadratic formula too, which my differential equations teacher, who had her PhD in physics, said that she would always just skip all that factoring nonsense and use that quadratic formula. Now I know right here, remember these are being multiplied, so I could set this x minus 6 equal to 0, which will make my whole denominator equal to 0, and I could set the x minus 7 equal to 0, which would make the whole denominator equal to 0 because they're being multiplied. This means that x can't equal 6 because that would cause it to be 0, so there should be an asymptote there. Ooh, more than one vertical asymptote? Yes, rational functions have more than one. I guess some reciprocal could too. So those would be where the asymptotes are. So what are the equations for the asymptotes? X equals 6 and x equals 7. Vertical. Oh. And horizontal. I almost missed that. Just says all of them, all of the asymptotes. Why can't y equal 0? Is there any possible way to get the output equal to 0? And there isn't. Okay, good thinking. Oh, see, they factored it for you. Let's move on. We're going to move on to the quiz now so I can help you guys with this. Thank you for watching. Please remember, it's